Hello friends, this is Gaurav and I am here to give a presentation on a topic AM reception. Today we will discuss some topics on AM receptions, that is characteristics parameter of a receiver, selectivity, sensitivity, fidelity and image frequency. And the other topic is tuning and tracking of SHT. The question arises in your mind is, what do you mean by AM reception? So, AM reception is affected by walls of brick, metal or concrete, not to mention aluminum siding. Other potential sources of interference are electrical devices in your house, anything from a fluorescent light to a TV. Try positioning the radio away from these things or switch them off while you are enjoying the ball game. Characteristics parameter of a receiver. A receiver operating characteristic curve or ROC curve is a graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. The ROC curve was first developed by electrical engineers and radar engineers during World War II for detecting enemy objects in battlefields and was soon introduced to psychology to account for perceptual detection of stimuli. Types of characteristics: selectivity, sensitivity, fidelity, image frequency. Um, First one is sensitivity. Sensitivity of a receiver is its ability to identify and amplify weak signal at the receiver output. It is often defined in terms of voltage that must be applied to the input terminals of the receiver to produce a standard output power which is measured at the output terminals. Sensitivity is also known as receiver threshold. It is expressed in microvolt or decibels. As you see in this graph, frequency varies with the sensitivity. When frequency increases, the sensitivity in microvolt will be increases. Selectivity. The selectivity of an AM receiver is defined as its ability to accept or select the desired band of frequency and reject all other unwanted frequency which can be interfering signals. Adjacent channel rejection of the receiver can be obtained from the selectivity parameter. Response of IF section, mixture, and RF section considerably contribute towards selectivity. The signal bandwidth should be narrow for better selectivity. As you can see in this graph, selectivity curve is narrowed, so we will get a better selectivity. Fidelity. Fidelity of a receiver is its ability to reproduce the exact replica of the transmitted signal at the receiver output. For better fidelity, the amplifier passes high bandwidth signal to amplify the frequencies of the outermost sideband, while for better selectivity, the signal should have narrow bandwidth. Thus, the trade-off is made between selectivity and fidelity. Low frequency response of IF amplifier determines fidelity at the lower modulating frequency, while high frequency response of the IF amplifier determines fidelity at the higher modulating frequency. Image frequency. Image frequency is the problem of receiving two radio stations simultaneously at the same point of receiver dial. Image frequency is denoted as FSI, which is equal to Fs plus 2 into IF. For example, suppose the receiver is tuned to pick up a signal on a frequency of 600 kHz. The local oscillator will be operating at a frequency of 1055 kHz. Then the received and local oscillator signals are mixed or heterodyned in the converter stage, and one of the frequency resulting from the mixing action is difference between the two signals, that is 455 kHz, the IF frequency. Tracking. The receiver has a number of tunable circuits such as antenna or a mixer or a local oscillator tuned circuit. All the circuit must be tuned correctly if any station is to be tuned. For the reason, the capacitor in the various tuned circuit are ganged. which means mechanically coupled to each other. Due to this arrangement, it is possible to use only one tuning control to vary the tuning capacitor simultaneously. The local oscillator frequency f0 must be precisely adjusted to a value which is above the signal frequency fs. The if is that f0 is equal to fs plus if. If this tuning is not done precisely, then the frequency difference is that f0 minus fs is not correct. There are two types of tracking. First is 2-point tracking, second 3-point tracking. In the 2-point tracking, there are two subtypes, that is padder tracking, trimmer tracking. So here we're discussing 2-point tracking. When you use two trackers in the match move behavior, 2-point tracking motion analyzes and record not just the position parameters but also the scale and rotation parameters. You can manually disable any of these parameters in the adjust row of the behavior inspector to achieve different effects. First is padder tracking, second trimmer tracking. As you can see in these figures, padder tracking. Padder tracking consists of inductor, capacitors, and also contain two circuits, that is antenna tuned circuit and local oscillator tuned circuit. And also in the trimmer tracking circuit there are inductors, capacitors, and and these are also contain two circuit, that is antenna tuned circuit and local oscillator tuned circuit. There is some circuit difference, that is capacitor is a capacitor in padder tracking is connected in series, and in trimmer tracking circuit it is connected in the parallel. Um, in this 3-point tracking, uh, there is also two circuit which is connected, that is antenna tuned circuit and local oscillator circuit. This combines the padder and trimmer tracking system, which means in this 3-point tracking circuit, uh, there is a combination of padder and trimmer tracking system, which is come to join, which is combined, um, and the 3-point tracker is introduced. The three frequency of correct tracking is that at which zero tracking error exists at normally 600 kHz, 1500 kHz, and the geometric mean of the two is 950 kHz. It is possible to keep the tracking error below 3 kHz. Thank you.